If f of x is 2x plus 1 and g of x is root x, we want to find g of f of 4. So that's going to be g of, let's put 4 into f, and then that's 2 times 4 is 8, add 1 is 9. And g is the square root function, so that's the square root of 9, giving us 3. Is g of f of x a function? Justify your answer. Well, let's think of g of f of negative 5. That's g of, if we substitute negative 5 into here, we get negative 10 add 1 is negative 9, which is the square root of negative 9. And that cannot be done in reals, and we are dealing with reals in functions. Therefore, it's not a function for all x belonging to reals. All reals can go into f, but the output from that can't all go into g. So can we make it into a function by using a particular domain? And that's what we're asked to do in part C. Determine the natural domain and range for g of f of x. So our problem is the g of x. If we think about square root of x, the input into this has to be reals greater than or equal to 0. So we're going to need the 2x plus 1 to have output greater than or equal to 0. Just let's take a minute before we do that. Let's actually form an expression. So we know that x is going to go into f first. The output from that will be 2x plus 1. That's then going into the root function. So the output from that is the square root of 2x plus 1. So what we're going to need is for 2x plus 1 to be greater than or equal to 0. So 2x is going to be greater than or equal to negative 1. X has got to be greater than or equal to negative a half. So provided we have that, x is a real, so this is the domain, x is greater than or equal to negative a half, we can have g of f as a function. With this domain, going into the square root are reals greater than or equal to 0. And if we think about the square root graph, that's also the output. So the range will be all reals greater than or equal to 0.